Let's now look at the trabeculae that crisscross the red pulp. These finger-like projections of smooth muscle or dense connective tissue have two functions. One is to physically support the mass of splenic pulp, which otherwise would have the consistency of a very soft jelly. The other is to provide passageways for the larger arteries and almost all the veins that run within. The trabecular arteries and veins run down the middle of the trabeculae. Remember that the blood's been flushed out from them. The veins have no wall of their own, other than a thin sheet of endothelium. So they look like large, irregular cavities in the trabeculae. Close inspection will show the flattened nuclei of the lining endothelium, identifying them as blood vessels instead of just artifactual spaces. Trabecular arteries have a more definite structure, with a well-developed tunica media. The smooth muscle of that layer is circularly arranged. Look at the smooth muscle layers here, and longitudinally sectioned over here. The trabecular arteries also have an adventitia layer of dense connective tissue. In some places, this is hard to see, but in others, where the tissue has shrunk, the adventitia has pulled away from the wall of the trabeculum. The artery then appears to be floating in a hole in the trabeculum. Arteries run for a shorter distance in the trabeculae than do veins. Therefore, you're going to see more sections of trabecular veins. The reason for the difference is that the trabecular veins run for a considerable distance in the pulp as central veins. Pulp veins are almost too short to notice, but here is an example of where the sinusoids seem to drain directly into a trabecular vein because the pulp veins are so short. You'll recall that the internal organisation of reticular tissues is programmed to be by the reticular cells anchored to reticular fibres. Look at these fibres surrounding the sinusoids like claws, helping to create slits for red blood cells to pass through.